algebra students. This is Mr. Ward. We're going to do day 3 on our exponential functions unit, which we like to call J-graphs. We're going to look at our equation today, and we're going to talk about when they're increasing frontwards J's or decreasing backwards J's, and how to tell. Also, we're going to have a new term we're going to call increasing growing or growth. Decreasing is decaying. Decrease, decay. How can we tell by just looking at the equation? Well, it's all about the b value. And for growth, the b value has to be greater than 1. For example, if the b was 2 or if the b was 5. That would give me a frontwards j that would increase or grow, and it would look like that. On the other hand, if the b was less than 1, which means a fraction, like 1/2, or a decimal, like 0.1, that would mean the j would be backwards, it would be decreasing, or decaying. So we're going to look at the graphs to determine, and we're also going to look at the functions themselves to determine if we're looking at growth or decay. So let's start with our first two examples. That frontwards j, example 1, that is definitely growth. That would have a b greater than 1. The second one is a backwards j, definitely decreasing or decaying. All right, example 3. We have a function. How can we look at this? And that b is 3. It's a whole number, so I think I have an idea, but let's use our calculator, make our table and graph, and then take a look at the picture. So it says y equals 3 caret, get that little x, exponent x, 3 to the x. Second graph, let's get our table. It says start at -3. So -3 is 0.037. We're going to use money and call it 0.04. -2 is 0.111. You can call it 0.11, or I know a lot of you guys know 0.1 repeating. -1 is 0.33, or 0.3 repeating with a bar over it. And then we have the whole numbers 1, 3, 9, and 27. So let's plot these points. And let's see if this baby is growing or decaying. The decimals are a little hard to plot. Let's plot the whole numbers first. 327 over to 3 and up to 27. Too big. So we're not going to do that one. We're going to start at 29. Over to 2, up to 9. Over to 1, up to 3. Don't go over, just go up 1. Now where would -1.3 be? Well, 0.3 is between 0 and 1. So I'm going to put a decimal right about there. And then 0.1 is closer, and closer for 0.04. So it gets closer and closer to that x-axis. But that right there is our j-graph. And now we can look at it and say that's a frontwards j, so it is definitely growing. And b is indeed greater than 1 because 3 is bigger than 1. Absolutely. All right, let's keep going. We've got our next example. G of t equals 4 times 1/2 to the t. Now the question becomes, is 4 we're looking at or the 1/2? And the answer is, since our normal equation is y equals a times b to the x, it's the b that's important. It's going to be the 1 in parentheses. And that's a fraction, so my guess is, I think it's going to be decay. I'm going to put a question mark there. All right, let's plug this into our calculator. We're only going to plot a couple points, just enough to get our j. Y equals, let's clear out what we have. Write it just like it looks. 4 parentheses. Alpha, y equals fraction 1 over 2. Get out of the fraction, parentheses, caret x. Remember, we don't use t's, we always use x's. So I could hit the graph if I wanted to get an idea. Sure does look like it's decaying or decreasing. Now let's get a couple values and plot. Let's see what we have for a grid. We can go as high as 10, so that 32 doesn't help us, that 16 doesn't help us, but the 8 does. So let's go. -1, 8, 0, 4, 1, 2, 2, 1, and 3, 1, half. Let's move our calculator out of the way for a second. -1 to the left, 8 up. Don't go over, just go up 4. 1 to the right, up 2. Over 2, up 1. And over 3, up a half. Again, somewhere between 0 and 1. And if I connect all these, I get this nice backwards J decreasing. Remember when you draw it, don't go over the x-axis. And we're going to circle. It's definitely decaying. All right, example 5. This one's a decimal one. 4 times 0.6. And again, the 4 is not the important one. It's the 0.6. 0.6 is a decimal or less than 1. So again, I'm going to guess decay. Let's see what happens. Go to our calculator. Let's get rid of what we have. 4, just like it's written, parentheses, 0.6, parentheses, caret x. Frontwards J, backwards J. Let's hit graph, backwards J. This time, we're telling you what x's to use for your table. We're going to start at -1, 6.66. I'm going to use that bar. 0 is 4. 1 is 2.4. 2 is 1.44. 3 is 0.86. And 4 is 0.52. Because that 8 would make the 1 jump up to a 2. And if you wanted to, we could circle the fact that it is indeed decaying or decreasing. And let's plot. When x is -1, 1 to the left, y is 6.6, bigger than 6 but smaller than 7. Don't go over, just go up to 4. Over 1 to the right, bigger than 2 but smaller than 3. Over 2, bigger than 1 but smaller than 2. Over 3, smaller than 1. And 4 is even smaller. And there's our backwards J. Let's connect them all. And again, make that arrow go out, but don't cross the x-axis. Looks like that. Sorry, I missed my dots a little bit. My smartboard is still a little bit off orientation. All right. So tomorrow, what we're going to do is we're going to look at decaying, but we're going to make up some equations using those A and B values. So I hope that went well, guys. Have a great rest of your day, and make sure you work on this class work day 3 assignments. Get some practice on this grow and decay. Excellent. Have a good day.